Alright, so this section's all about inverse trig functions. So the idea is if I have something like, say, sine of theta equals 1/2, right? In that situation, we're looking at the first quadrant here, and we're looking at 30 degrees. If I look at 30 degrees, that's that point right there is root 3 over 2, 1/2. So sine of theta, so in this case, theta is equal to 30 degrees, right? So the idea behind the inverse trig functions is that if I take, if I know that sine of theta equals 1/2, that's, I want to be able to go backwards and say, well, if I know that sine of theta is equal to 1/2, what is theta? So the idea here would be that looking at this sine of theta equals 1/2 equation, if I were to take inverse sine of both sides, ideally that would give me 30 degrees, right? So that's the idea behind these inverse trig functions. Now, first thing I want to make sure we're clear about is just like f inverse, like f to the -1 of x, just like that is f inverse, not f to the -1 power. Same thing here. This -1 up here, that's not sine to the -1. That is sine inverse, inverse sine. Also, sometimes you'll see that referred to as arc sine of theta. So, or sorry, not of theta, of 1/2 in this case. And that gives us theta. So our trig function takes us from an angle to this ratio, right, to the y value, if you will, and the inverse function takes us from the y value back to the angle. So let's do another example. Suppose I have inverse cosine of, oh, let's say, oh, let's just do 1. So inverse cosine of 1. What that means is saying cosine of what angle gives me 1. So I'm looking at where is my x value equal to 1. Well, notice it's right at that spot, so I would probably say, well, that angle is equal to 0 degrees. Now, you might say, well, how do I pick 0 degrees? Why is it not 360? Well, that's where our definitions of our uh, inverse functions are going to come into play. So if I look at sine inverse is going to give me a value on the right half of the circle from -pi over 2 to pi over 2. So let's take a look and suppose, or excuse me, sorry, or from -90 degrees to 90 degrees, depending on what we're talking about. All right, so let's take a look at some more examples. Now, if I say sine of theta is equal to root 3 over 2. Let's look at our unit circle and see where does sine of theta equal root 3 over 2. Well, if you look at it, this point right here is 1/2 root 3 over 2, and this point right here is -1/2 root 3 over 2. So, if I'm talking in degrees, notice that this is 60 degrees and this is 120 degrees. Now, how do I decide whether sine inverse of root 3 over 2, how do I decide, is that equal to 60 degrees or is it equal to 120 degrees? Well, what we're going to do is we're going to pick the value that's on the right half of the circle between -90 and 90 degrees. So in this case, it's going to equal 60 degrees. The reason for that is if we don't, then it's not a function. Remember, a function takes, it says if I have one input, I have one output. So I need to pick something. There are infinitely many angles where sine of theta equals root 3 over 2. So, but I need to pick one. And so we decide that we're going to use a number on the right half of the circle from -90 degrees to 90 degrees. And why do we pick the right half of the circle? Because we hit every y value on that right half of the circle, right? We go from -1 up to 1. All right, so similarly, if I look at, say, where does cosine of theta equal 1/2? Well, if I look at my circle, I've got it, or I've got 1/2 root 3 over 2, or I've got 1/2 negative root 3 over 2. So you could look at this a couple different ways. You could look at it and say, well, This angle right here is 60 degrees. This angle going all the way across or around is 300 degrees. Or you could look at it and say, well, that's negative 60 degrees. All of those things, all those angles have satisfy that equation, cosine of theta equals 1/2. But I need to pick one value, right? I need it to be a function. So if I wanted to say what is cosine inverse of 1/2, what I'm going to do is I'm going to pick something from the top half of the circle. So cosine inverse of 1/2 is going to be 60 degrees. Does that make sense? Thinking about it again, it's got to be the top half of the circle. Now, why do we use the top half of the circle for cosine? Because notice I hit every x value, and cosine represents the x value on my unit circle, hit every x value from 1 to -1. If I did the right half of the circle again, I would only get positive x values. So cosine inverse has a different definition. Finally, tan inverse has almost the same range, except remember tangent does not exist when x equals 0, so it's from negative pi over 2 to pi over 2, but we don't include the endpoints. But so sine and tangent are very similar. They look at the right half of the circle. Cosine inverse looks at the top half of the circle. So let's do a couple more examples. So suppose we have, I want to figure out what is sine inverse of 3. Now let's think about what, remember we're saying what angle in the right half of my circle gives me a y value of 3. Well, nowhere, right? The sine of theta is always between -1 and 1. Our y values never get bigger than 1, never get smaller than -1. So I can't actually plug that in. So this does not exist. It's undefined. So looking at sine inverse of x, we've got our domain is -1 less than or equal to x less than or equal to 1, and our range is negative pi over 2 less than or equal to y less than or equal to pi over 2. Again, I'm thinking y equals that. So our domain of that function is -1 to 1. Our range is negative pi over 2 to pi over 2. Now for y equals cosine inverse of x, our domain is again -1 to 1. And our range, remember it's the top half of the circle, so it's between 0 and pi, or 0 and 180 degrees, if you will. And finally, y equals arctan, or inverse tangent. Our domain, in this case, if you think about it, is there anything that we the tangent value cannot be? Well, tangent gives me a values from negative infinity to negative or to positive infinity, so the domain is all real numbers. The range is the right half of the circle, but this time, let's keep the same notation. This time it's negative pi over 2. It's less than, not less than or equal to, y less than pi over 2. All right, so those are our definitions of our trig function. So let's do just a couple more examples. Suppose I have, let's find sine inverse of sine of pi over 3. Well, remember how inverses work. I have sine of pi over 3, so that gives me a y value. Sine inverse should take me back to my angle, so this is going to equal pi over 3. Again, let's draw a picture. Pi over 3 is this angle right here. So I look at that and I say, well, that's 1/2 or 3 over 2. So the inside there gives me sine inverse of root 3 over 2. And now I say, what angle gives me root 3 over 2? Well, pi over 3. Now, what if instead I say sine inverse of sine of 2 pi over 3? Well, let's look at how this one works out. You might be tempted to say that that's equal to 2 pi over 3, just thinking, oh, these two cancel off or something like that. But that is not the case here. If we look at 2 pi over 3, That's this angle here. Our point is negative 1/2 root 3 over 2. So notice I get sine inverse of root 3 over 2. Now notice these two are the same. So I should get the exact same answer. So pi over 3. So what ends up happening is, remember what I said, it always spits out numbers that are on the right half of my circle. Would 2 pi over 3 be on the right half of my circle? No. It's in quadrant 2. I need something in quadrant 1 or 4. So I instead look at what is the part in the right half of the circle that has the same y value. And I see, oh, it's this guy right here, pi over 3. That has the same y value. And so I end up with that as my answer. So let's try another one with cosine. Suppose I have cosine inverse of cosine of, oh, let's say 7 pi over 6. Now again, 7 pi over 6, the range of inverse cosine is going to be the top half of the circle. 7 pi over 6 is down here. So I need to somehow figure out the angle in the top half of the circle that gives me the same x value as the bottom half of the circle. So notice these 2 points here have the same x value. They're both negative root 3 over 2. This one's a positive 1/2 for the y. This one is a negative 1/2 for the y. There's my minus sign. So these have the same x value though. We're going to pick the one, when we're finding inverse cosine, we got to pick the one in the top half. So I see that this is equal to 5 pi over 6 because that's what this angle is. This angle here is 5 pi over 6. So hopefully that gives you a kind of a clear idea of how these inverse functions work. So this video is a little bit longer than some of the others, so hopefully you were able to bear with me, but I think these inverse trig functions can be tricky for some people. So as always, ask me any questions that you have.